Greetings everyone, my name is Ajir. In a series of videos provided for you, I am going to thoroughly explain how to compute limits of function in technical and order steps. Please be kind enough to subscribe to my channel to keep up with the following videos and comment down below if you have any question. Thanks for your kind attention. The strategies compute limit of function which I summarized in 16 steps through the example which I provided to explain how to compute limits of function. First of all is substitution, which is common in computing every function or the limits. Let's start with the first example. For example, one strategies to compute limit of function which I summarized in 16 steps, and I will present every step with some examples. Let's start with the first step, which is substitution. First strategy is substitution. When we want to compute every function, limit of function, we have to replace first the value in terms of the variable. Now it's a t approaching to 0, so we have to put 0 instead t, so we will get 0 plus 6, it's 6 over 0 minus 3 is minus 3, that we get minus 2. Here, without any challenging way, we got minus 2, and we didn't face with any indetermination form. The problem appears when we see some thing which is not defined. Some terms like 0 over 0 or 0 time infinity or infinity time infinity and 0 power infinity, infinity power infinity, 1 power infinity. That all are the form of indetermination. When we go to some example and we see how we can compute the function of limit of function when we facing with these things. So those so these all of these are the form of indetermination. So we have to get rid of this indetermination form, and through this strategy and example we are going to find out how we can solve these to get rid of this form of indetermination. Indetermination form is 0 over 0 in infinity over infinity, infinity minus infinity, 0 point infinity, 0 power 0, 1 power infinity by infinity power 0. Some determinate form also infinity plus infinity is infinity, minus infinity is minus infinity, 0 power infinity is 0, 0 power minus infinity is infinity, and infinity times infinity depend on this will be positive or negative. If here one of these is minus infinity, so we get minus infinity. So we have 7 form of indeterminate which we have to get rid of from this, and let's do the example and steps, see how we can uh, work with this form to get rid of from indeterminate forms. The example here is for simplifying. We have the limit of 1 plus h exponent 4 minus 1 over h when h approaching to 0. First of all, we substitute 0, so here we will get 1 minus 1 is 0 over 0. So this is in the determination form. To get rid of this indetermination, we have to simplify this term. We can not choose, just we can expand and simplify this form. So we can delete the factor which made this indetermination form, that is h, because h minus 0, h minus this value, whatever it is the factor which made this indetermination form. So we have to make the h in numerator and then the delete with h which is appear in denominator. So we have to expand this part. If we go back the formula for expanding the 1 plus h to exponent power 4, we have this formula, and this formula is according to the Pascal binomial, which is defined here, a plus b power n equal to these terms, and formula for the binomials a plus b power n, we have this formula, the combination n from n, a n, and this combination n in up is same in up row, and here one units will decrease from n every time, n, n minus 1, n minus 2, n minus 3, and the last n minus n, and we have a b term with powers, which first is n exactly, and b power is 0. Here every time decrease from n, n minus 1, and we'll add to power of b, b1, n minus 2, n minus 1 minus 1, and 1 terms will add to b, 1 plus 1 is 2. So always pay attention that the summation of this power should be n. N minus 1 plus 1 is n. Exactly the power we want to produce. And let's come to a plus b power 4. So we will have here, we can put 4 instead n, we can get this term, And one that you will easy compute. I will teach you how you can for any term with any power. Here is 4. First we will put a4 and the power b is 0. And next 4 coming coefficient, and from 4 will decrease 1 unit, we will have 3, and it will be added to the power of b. So we will have 4a3b1. And next term we multiply 4 in 3, we will get 12. Let's I write here. So here we have 14. Sorry. Here 4 times 3, 4 times 3, 4 times 3 over how many terms it's passed 2. So we have 12 over 2, it's 6. And next time we time 6 into 6 times 2 over how many terms it's past 3. So divided by 3. So we will have 12 over 3 is 4. And next time 4 times the power of a is 1. 4 times 1 over how many terms past 4. So we will get 1. So we come back to the example. So we will have here limit of, we expand this one, 1 plus 4 is coming here, 4h, because 1 it was 4 and h was 0. 4 is come here, and from the power of 1 it was 3, it decreased and add 2h. And here we have 4 times 3 because the power of 1 is 3 divided by 2, so we have 6h2 plus 4, we have excuse me, 4h3 plus h4. And here we have minus 1 over h when h approaching to 0. So we can delete 1 and 1 from this. And now the factor which we have to get rid of, it is h. So we can factorize from h power 4 plus 6h plus 4h2 plus h3 divided by h when h approaching to 0. So h and h will be deleted. Now by replacing 0 instead of h, these terms will be 0, so we will get 4. And in the simplification step, any term we found that it needs to simplify to make the factor which made indetermination form for this function, we have to simplify or expand. Let's come to factorizing, which we have more example in this. It was the 3 steps for this purpose. The third strategy is factoring and cancelling, which consider some question here. The first is the limit of x3 plus 8 over x2 plus 8 is plus 12 when x approaching 2. I put minus 2, so I have minus 8 plus 8 over minus 4, positive 4, minus 16 plus 12, that is numerator is 0 and denominator also will be 16 minus 16 equal to 0. This is the form of indetermination which I have to get rid of from 0 over 0. So for this I have another steps as simplification and also factoring and cancelling. Here is the factoring and cancelling steps because I can't simplify this one. So in order to remove from form of 0 over 0, I want to factorize. How to factorize here? I can do here in terms of some facts that here I can use x and here 6 and 2 because time 6 and 2 will be 12 and adding together I will get 8. Here I have x3 plus 8, so I can write as x plus 2 times x2 plus 2 plus 2, 4x, that will be negative, here plus 2. So here when x approaching to minus 2, I had provide x plus 2, x plus 2, which is the root and the factor which made 0 and 0. So I can cancel this factor from denominator and numerator, then we can easily reach to here. Now I can substitute example steps. So I will put minus 2, I will get 4 plus 8 plus 4 over minus 2 plus 6, that I get 4. So here 16 over 4, which I reach to 4. Let's start with another example here. I have the limit of this t2 plus 6t plus 5 over t2 plus 2t minus 15 when t approaching to minus 5. Substitute according to step 1, so I will get minus 5 square, it means 25, 5 times 6 minus 30 plus 5, and here 5 square, 25, 5 times 2 minus 15. So I will reach to 0 over 0, so I have to get rid of these steps. So what's the factor which I have to make as 0 in denominator and numerator is here, because t approaching to minus 5, so t plus 5 going to 0. It means this factor, I have to make this factor in both numerator and the denominator. So here I can do factoring. I can write as, here so how can I factorize here? I can write here as t, and this is the multiply of two numbers, and each adding two numbers I got 2. So here I can write 3 and 5, but 1 is negative as here is positive, so the larger here 1 is positive, so here is negative, here is positive. So here I made t plus 5. Let's switch numerator. Here t and t. If I write here, I can very easily switch to 1 and 5, because time of 5 and 1 is 5, and adding together is 6. Now I had reached again to this, which I can cancel t plus 5, which is the factor of making 0 for both denominator and numerator. So here I will reach to this one. When I substitute, very easy to get rid of from 0 where 0. So I put minus 5 and I will get minus 4 over minus 5 minus 3 is minus 8, so I will reach to 1 over 2. Number 4 is make common factor of root in denominator and multiplying in conjugate factor. Let's come up with this example. We have here this example, and we should multiply in conjugate term which is appear in denominator. For example, the limit of z minus 6 over the radical of 3z minus 2 minus 4 when z approaching to 6. If I substitute for first step, which we do in all computing limits, so I put 6 here, I will get 0, and if I put 6 here, 3 times 6 is 18, minus 2 is 16, and the square root is 4 minus 4, so we will have the 0. So here we should get rid of from the factor of z minus 6. So the factor is this one. We should get rid of this in determination 4. So to remove this form, I will see here the radical. So if I return to this, before here we have mentioned that we can factor cancel and make common factor of root in the denominator by multiplying in conjugate factor. So we need to use this 4 factor here. Let's use the conjugate factor here, which is this factor, radical a minus radical x time radical a plus radical x, we will get a minus x. So if I times in this I will have the limit of minus 6 radical 3z minus 2 minus 4. I write with another pen color 3z minus 2 plus 4 is the conjugate form of this one. So I will again multiply in numerator. So here if I multiply together, I will reach to the limit of get 3z minus 2, and here 4 power 2 will get 16, and here it will be kept. I need this factor, so I don't multiply in this conjugate form. Is 2. Now when z approaching to 6, I will have 3z minus, here together is minus 18. So I can, for reaching to this z minus 6, I get the factor from 3. So like I write here 3 z minus 6. Now z minus 6, the factor which we wanted to cancel, it will be cancelled. So here I can have this one. If I put z equal to 6, we will have here 16, which the square is 4. So 4 plus 4 over 3, that I reach to 8 over 3. Now here we have another example of this limit, and as you see here, when she approaching to 3, if I substitute here 3, we get 3 minus 3 is 0 over here 3 plus 1 is 4, and the roots square is 2 minus here 5 times 3 is 15 minus 11, so I will get 16 4 sorry, and the square is 2, so 2 minus 2 is 0. So here they should remove this indetermination form. Let us see what we can use. Here again we have the radical, and we can use again number 4, conjugating, multiplying in conjugate factor. So I use number 4 conjugate. So I multiply in conjugate form of the denominator, which is limit of 3 minus t, and here radical t plus 1 minus radical 5t minus 11, and the conjugate form is equal to radical t plus 1 plus radical 5t minus 11. Again I can reach here radical t plus 1 plus radical 5t minus 11. So here equal to when t approaching to 0 to 3, sorry, and if I multiply together, I will get t plus 1 because the exponential 2 of this will remove the radical, and minus 5t minus 11. If I apply minus in t minus t, I will get for minus 5t plus 11. And here t minus t, and here radical plus 1 minus radical 5t minus 11, and the conjugate form is equal to radical t plus 1 plus radical 5t minus 11. Again, I can reach here radical t plus 1 plus radical 5t minus 11. So here equal to when t approaching to 0 to 3, sorry, and if I multiply together, I will get t plus 1 because the exponential 2 of this will remove the radical, and minus 5t minus 11. If I apply minus in 5t minus t, I will get for minus 5t plus 11. And here t plus 1, t minus 5t is minus 4t, and here I have t plus 1 plus I will get 2. And here again I will write, because I need the factor of t minus 3 here. This factor I need. So I don't touch this one. And radical of t plus 1 plus radical of 5t plus 11. When t approaching to 3. So here I can factor from 4 or minus 4. So I will get the limit of, I write here, minus 4 t minus 3. So t minus 3 with 3 minus 3 will go on with just only this negative, also will go. I think it was better I don't get minus for not making you confused. And here we will get from 4 I have minus 3 plus 5. So I will remove these parts together. 3 minus t and 3 minus t will go on. So if I substitute here, 3, I will get 3 plus 1 is 4 radical, will come out with 2, and 5 times 3 is 15 plus 11. So I will have 15 plus 11 is 26. Sorry, it is minus here. I apologize. Here I have the minus. So here I have the minus. So here 5 times 3, I will have 15 minus 11. I will have 4. It's come out 2. So I have 2 plus 2 here over 4. 4 over 4, I will get 1. So the answer of this limit will be 1. This is end of section 1 from this series of computing limits. You can keep up with the following topic in the next video in section 2. Thank you for your kind attention.